Hello, this is going to be a continuation of our connective tissue notes that we started yesterday or on Tuesday if you were in class for them. So we had left off with adipose tissue, which is fat. Today we are starting off with reticular connective tissue. Reticular connective tissue is named for reticular fibers, so it's mostly made of reticular fibers. It supports internal organ walls. We find this in the walls of the liver, the spleen, lymphatic organs. So there's going to be fibroblasts, and they're going to make all of these reticular fibers that are made of the protein collagen to support other cells in these organs. Next, we have dense connective tissue. I've talked about this one with you before. So dense connective tissue has packed collagen fibers. So we have these parallel collagen fibers. There's going to be a few elastic fibers. There's a few fibroblasts that are making the fibers. They bind structures together. They are ligaments and tendons are going to be what are made of dense connective tissue. They have very poor blood supply. Once these ligaments and tendons are created, they are pretty much in stasis. These fibers are proteins. They don't have a need for blood supply. They don't have a need for oxygen. Next, we have elastic connective tissue. It, of course, has abundant elastic fibers. There are some collagen fibers as well. It has fibroblasts, which are the cells responsible for making fibers. It has going to form attachment between bones. It is going to be found in the walls of large arteries, airways, and the heart. So this is a somewhat stretchy tissue. We find it in arteries and airways where it needs to have some degree of give. Next, we have bone, which is also known as osseous tissue. If you see words that start with osse, that is going to indicate that they have a relationship to bone. So, bone is different from all the tissues we've had prior because it has a solid matrix. The matrix is solid instead of being fluid or gel or near gel like a tendon. It has a solid matrix. So your bone has a few functions. It protects, it supports, it provides framework, it forms your blood cells. Your blood cells are produced in your bone marrow. It serves as attachment point for your muscles. It forms your skeleton, of course. Your bone is a living tissue. It has cells, osteocytes. These osteocytes, if we were to look under microscope, we would see these circular structures. They look somewhat like tree rings. So we have osteocytes in lacunae. Next, we're going to get to cartilage. There's going to be 3 different types of cartilage. So cartilage has a rigid matrix. It's not what I would call a liquid. It's not a gel, but it's definitely not a firm, solid either. So it has chondrocytes in lacunae. It has a poor blood supply as well. So there's going to be 3 types of this. You have hyaline cartilage between your bones. This is the cartilage that allows for joints to glide over themselves. You have elastic cartilage. You know your elastic cartilage is in your ears. It's very nice and flexible. I can take my ear and fold it over. Then we have fibrous cartilage. Your fibrocartilage we find in the pads of your spine. Sorry, I wanted to grab Mr. McCoy because he'll be useful for his fibrocartilage he shows us. So haline cartilage is the most abundant. We find this at the end of your bones. We find this in your nose has haline cartilage, your respiratory passages, your embryonic skeleton. As your skeleton developed, it started as haline cartilage before it ossified into bone. So if you want to know what haline cartilage feels like, take the tip of your nose. That is haline cartilage that you are moving around. Next, we have elastic cartilage. Elastic cartilage is more flexible. We have this in your external ears, so my external ear is far more flexible than the tip of my nose. We also have this in your larynx. Last, we have fibrocartilage. So fibrocartilage is very tough. It serves more as a shock absorber. You have fibrocartilage between all of your vertebrae. All of these intervertebral discs are fibrocartilage. You also have a little bit of fibrocartilage between your pelvis, right there. Get this guy back on a stand. So, I believe our last connective tissue we're going to talk about is blood. So blood has a fluid matrix. We call this fluid matrix plasma. So your blood is going to contain red blood cells, white blood cells, and platelets. Your blood is going to transport. It's mainly going to transport oxygen, carbon dioxide. It is going to transport sugars and other nutrients around the body. It defends. That is the role of the white blood cell. It's involved in clotting. That is the role of the platelets. We have blood throughout your body in blood vessels. Your heart is, of course, responsible for the pumping of this blood. So you have many types of blood cells. This has all of them at about the same scale. So you have a couple different types of what we call white cells. These are the ones that are involved in your immune system. Your red cells are known as erythrocytes. Then you have these smaller platelets. So that is the end of our connective tissue notes. Tomorrow we are going to go through the muscular tissue, and we are going to go through nervous tissue. So don't forget to like and subscribe.